Today we're going to go through how to answer these energy calculations. Now this workbook, I'm going to put a link in the comment section here so you can download the workbook first. Please have a go at these questions before you see the answers. So question 1 says calculate the gravitational potential energy. So it's always good practice to write out the formula that you're going to be using, even if you are given it on a formula sheet in the exam. So here we want gravitational potential energy, and that is equal to mass times gravity times height. So then we put the numbers in here, what we have. So the mass tells us it's 62.5, and the gravitational field strength, it says, is 9.8. So we're using that rather than 10 today. And then the height of the slide is 16. So you just plug that into your calculator and you should have got 9,800. At the bottom of the slide, the speed of the rider is 12 meters per second. The mass of the rider is 62.5. Calculate the kinetic energy. So again, good practice. Let's put in our equation here. So that's going to be half times mass times velocity squared. Now it's important that we square the velocity, we're not squaring the whole calculation. So let's put in our numbers here that we put into our calculator. So in this case here it's going to be 0.5 times the mass, it's 62.5, and it tells us the velocity there is 12. And 12 squared is 144. Okay, so that's a little sort of way to separate the calculation again. For some reason, the examiner do like to use 12 squared quite often. So when you plug that into your calculator, you should have got 45,000 joules. Here it says, again, we want to calculate the kinetic energy of the cyclist, so we still want to use that same calculation of half times mass times velocity squared. We're still using that. So we're going to put in 0.5. The mass here, it says, is 80. And then, once again, we use that 12 squared. Once we've done that, we've plugged that all into the calculator. You should have an answer of 5760. So obviously 1 mark for the answer and 1 mark for substituting the numbers into the equation. When the cyclist uses the brakes, the bicycle slows down, and we want to calculate the change in thermal energy of the brake pad. So for this calculation, you want to flick back through to specific heat capacity. Now the clue for this really is that we've got temperature being given here, we've got mass, and it actually tells us here is heat capacity. So that's why and how we're going to use that equation. And it says we want to calculate the change in thermal energy. So this equation here is going to be energy is equal to mass times the heat capacity times the change in thermal energy. So we then want to put in our numbers, substitute our numbers to this equation here. What's the mass is? Well, the mass is 0.04 times the heat capacity. That's 480, it tells us just here. And the change in temperature. Now it's increased by 50, so that's our change. There's no more sort of conversions that we have to do there. And we can then plug that into our calculator and we'll get an answer of 960. So it's 2 marks available here, 1 mark for the correct answer and 1 mark for the substitution of the numbers there. No rearrangement needed. Question 3 here on this question. It says here, calculate the energy stored within the stretch bungee cord. So for this equation here, we want to use the elastic potential energy. And that's going to be half times the spring constant times the extension squared. Very similar, you might notice, to our kinetic energy calculation. So again, it's 2 marks, which gives us a clue that there shouldn't be any rearrangement to do, nor should there be any conversions to do. So we then put in our numbers, so it's half 0.5 times k, and our spring constant is here, which is going to be 40, times the extension squared. Now the extension squared, it says the extension of the bungee cord is 35 metres, so that's going to be 35 squared. And that will give us, as you plugged it into your calculator, an answer of 24,500. Again, for 1 mark for the substitution and 1 mark for the correct answer. When using a zip wire, the person moved through a vertical height of 2 metres, and we want to calculate the change in gravitational potential energy. So again, remember for this one here, for GPE, it's equal to mass GH. Put our numbers in here. What's our mass going to be? Well, it's 45 kilograms times G, and we're using 9.8, not 10 again, and then the height is 2. Again, it's just worth 2 marks, so that will be 1 mark substitution there. Once you put it into your calculator, you should get an answer of 882. It's always best to double check these calculations with a calculator as well. A drone can fly for 25 minutes before the battery needs recharging. So that's going to be key part of the question potentially. Always good to highlight it. The power output of the battery is 65 watts. Calculate the maximum energy stored by the battery. So for this calculation, okay, what we want to be looking at is that power equals energy over time. And what do we have here? Well, it tells us our power. Our power is 65. And that's equal to the maximum energy. Now we don't know that, so that's going to be here, but divided by the time. Now the time is here. That's 25 minutes. And you remember for this calculation here, we need the time in seconds. So we want to convert that 25 minutes to seconds. So we times it by 60, all right, which will give us 1,500. At this point here, we're going to have to rearrange this calculation to make energy the subject. So energy equals then, therefore, power times time. So if we times 65, times that by 150, we should get an answer of 97,500 joules. And notice it's more than 2 marks, all right, because we've had to do a conversion and a rearrangement as well. So the number of marks will give you a clue to what we have to do. So the mass of the water in the kettle was 0.5 kilograms. The temperature of the water increased from 20 to 100, and the heat capacity is 4,200. Calculate the energy transferred. So again, it's that specific heat capacity calculation. So when we plug it in, it's mass times the heat capacity times the temperature changed. So let's see what we have. Well, we have the mass at 0.5. We times that by the heat capacity, 4,200. Water is always 4,200. It comes up quite a bit, so expect to see that. And times the temperature change. The temperature change is gone from 20 to 100, which means the change in the temperature there is 80 degrees Celsius. So we're going to put that as part of our calculation. So we times that together, put that into your calculator. There we have it. Next up, it says we want to calculate the energy transferred to change the water to the steam. So we've got 5 grams of water, and this time we're given the latent heat of vaporization here. So this calculation, again, it's the energy transferred, but it's the mass times the latent heat. You'll notice that we've got 5 grams here, but the mass here needs to be in kilograms. So 5 grams into kilograms is 0.005 kilograms. So for this calculation here, 0.005 times our latent heat, what's that, 2,260,000. Plug that into your calculator and you should get an answer of 11,300 joules. I'm going to stop this video here. Make sure you see part 2